Dear ladies and gentlemen, welcome on behalf of the Global I60 training team. In the following, you may listen and watch to the recording of the I60 broadcast session with the topic Agility and Open Source, Innovative and Fast IT. Niels Magnus, Cloud Architect of T-Systems, will be presenter.
Agility and Open Source, Innovative and Fast IT. Welcome to this bonus session for the new Cloud Thinking program. Today we will briefly recap the most important concepts of agility and link them eventually to another key concept, open source. My name is Niels Magnus and I'm an architect for the Open Telekom Cloud at T-Systems. I reach out to technical communities and have a long-term experience in IT consulting. I was editor and author for tech magazines. I did a lot of system engineering and have operations experience. And I'm a very big fan and advocate for open source software. I co-founded LinuxTag and I'm still a member of the board of the German Unix users group. But now let's head start with a look into the well-discussed concept of agility. It's a new approach to an old challenge: how to solve complex tasks. The classical approach in project management is decomposition. That means slicing up complex tasks into smaller, manageable ones and assign milestones to them. This is called the waterfall model. But there are issues with milestones. So think of a requirement. They are a priori unclear, often unknown or changing during the process. This model is not ready for the disruptive change we all talk all the time. The agile approach is different. We focus on the next achievable goal. We go with self-improvement and feedback loops. For your reference, I have listed here a part of the agile vocabulary you may have heard already. The main process runs in a circle. A minimum viable product, an MVP, is improved in a short, defined time frame, the iteration, transforming a working product into another working product with some more features. By the way, this does not work only in software development, but can also be applied to integration, configuration, or rollout activities. The time frame, which is typically 1 or 2 weeks, is called a sprint. After each sprint, the team focuses on the next increment. But which one? Agility supports the team with the concept of the business value, the practical advantage for users and customers. Once the business value is measured, the upcoming goal is set and the next iteration starts. So this feedback loop is common for most agile processes, and some of them have well-known names. The by far most well-known representatives of agile methods are probably Scrum and Kanban. But unfortunately, the least often implemented methods are also Scrum and Kanban. So, how come that? Most organizations adopt a mixture of the concepts. Something that a pragmatic approach is appropriate for their specific organization. But some others think this is the complete wrong way to do. So this is actually difficult. We like to advise you to start with the pure thing at the beginning and then go for subtle modifications in the process. this is the best proven way to start with agile methods. So let's dive a little bit into Scrum, the probably most often adopted agile framework. Ken Schwaber and Jeff Sutherland had some experience with project management since the 1990s. And in 2001, they published the so-called Agile Manifesto, which postulates a couple of new values you may have heard about. They derived, based on these new values, a new concept, a framework, which they called Scrum. Scrum is relatively easy to understand, but contains a set of rather rigid rules. So to actually understand Scrum with all its details, a 1 or 2 day training is probably suitable. But that's it after all. But there is a difference in just understanding and comprehending the idea and its implementation. And that takes time. Take this time and you get the most value from that. One of the key takeaways from this concept is the error culture. Make mistakes, but make them as early as possible. Risk even frequently risky activities. This sounds mad, but actually, if there is some risk in a process, in a product, in a configuration, it's better to have this issue popping up in a controlled environment than later in production. So Scrum helps you to apply some kind of routine to these kinds of tasks. Routine instead of drama, when everything is falling apart, is a major concept. Let me give you an astonishing example. Netflix invented in 2011 a concept called the Simian Army, which is a set of demons which just do a single thing. They select randomly one of their production servers and just shut it down without further notice. So this sounds like a very risky activity, but actually they were able to mature their software components in a way that it's robust against these extreme way of making errors. This is a very interesting concept. You can look this easily up under the keywords of the Simian Army, which is the tool set, and the Chaos Monkey, which is the explicit service that shuts down the single service. To summarize Scrum, I listed here its key features on a single page. It consists of short iteration cycles that transform one MVP into the next one, which is a presentable piece of software. Presentable means it's actually demoable. So you are able to show off your work in front of your co-workers and discuss with them and demo the new result. This obviously involves in a lot of feedback and communication with several stakeholders, and this is a complex task which is described in detail in the Scrum concept. To achieve these goals, you need a cross-functional team, but it's essential to assign full control and full responsibility to this team as long as it's working on the features. To be able to do so, you need a couple of tools and foundations. One is continuous integration, that at every keystroke, more or less, or at every single commit and change in configuration and the like, tests and tries the effects of your changes. This is called continuous integration. And the second important building block is open source software, because it's so well fitted into this ecosystem. We look into this in a moment. So, all in all, Scrum comes with strict rules. It has many fans in software development, but it can also be adopted to operation tasks as well, especially if you work hand in hand together with different people from different former departments like operations, development. This is where the term DevOps comes from. As a final remark, if you want to have a look into the actual Scrum, you can be certified. And there's a free trial, and I give you the web address here. As we have talked a bit about agile methods, you may wonder how to implement this in your unit, in your team. Do the statements on the right-hand side in the gray box look familiar? Classic IT avoids risk with a very static approach. So there are heavyweight processes. There is heavyweight reporting. You are forced to use proprietary tools and cannot pick them. There is a basis that is unchanged and which is very hard to change and adopt golden images. You get reminded on a rather Soviet 5-year plan approach to planning, which is kind of unflexible. This is what we call waterfall planning. Another typical example of classic enterprise IT is the silo structure. Complicated handovers and very narrow focused responsibilities. The typical case is the harsh distinction between operations and development teams. On the other hand, take a look to the left-hand side. The idea of Scrum and Agile methods is to be quick, to be fast, to be flexible. And this is actually a very inexpensive approach, since after a short bit of developing new software, it gets tested, it gets evaluated, and it is actually a step forward. You pass on to the next iteration, and so on and so on. And if not, you just make another round and adopt the way you're heading. Let me give you some advice for preparing your first agile steps. Start away with a small project you can oversee. Assign a manageable time frame to it. A few rules of the Scrum frameworks appear a little bit arbitrary or even awkward. So a lot of people are tempted to change the detailed rules of the framework. We advise not to do this, especially if you are new to the approach, because you learn best the benefits of the framework if you adhere to the rules, at least in the beginning. After that, it's fine to adopt these rules. The team composition is a major success factor in an agile project. In a cross-functional team, members of different skills and professions work close together. Think of a developer, network specialist, database administrator, and a software tester working together. The whole team takes responsibility for the overall sprint and its outcome. To allow for such a commitment, the team should be free from too many processes and reporting, as well as free to pick its own tools to deliver best results. The whole process is in the beginning often supported by some external experience, say an agile coach. And if the results look promising, make sure to replicate your success, split your teams and distribute the experience to other teams as well. In short, to launch your cultural change, you need some support from management that is actually backing your approach. You need some experienced help to get you started. It is important to have an open-minded team which is keen to self-improve, and you need to give and take feedback and exchange this feedback with your co-workers and your stakeholders. The quote, "Release early, release often," very well summarizes the new agile approach. It favors to go public even with minor changes and to adapt your direction based on peer review. The quote itself was coined by Eric S. Raymond back in 1997 in his landmark article, "The Cathedral and the Bazaar." This was one of the founding moments of the open source movement. It is thus a good link to another concept that has influenced modern IT like hardly anything else. Open source is a term most of you probably have heard of. What today is an established software development model started more than 30 years ago with some apparently nerdy license discussion. This second part of today's session straightens out some of the lesser known facts of open source and its application to modern IT. Open source comes with its own vocabulary. Especially the term open source itself is the subject of a lot of discussion. But for us it's fine to see open source just as a popular term, as an alias for the term free software, which is technically slightly more precise, but let's stick with open source in general. But the free in free software refers especially to freedom, not so much to no cost. And actually, freedom splits up into several nuances. So the nuances could be, for example, a right to distribute software and the right to inspect code. We look into this in a moment. Even if free software is called free, it does not mean that you are not allowed to sell it for real money. Effectively, a lot of companies do this, and this is completely legit. And as a fifth point, free software is not the same and not even similar to freeware or shareware, because freeware and shareware don't assign some of the freedoms we are talking in a second to you, the software users. In freeware, you give up any rights on your software if you are the owner of the software. That means everybody who gets a grip on your software can do with it whatever he wants, even to put it under a new license and relicense it from this point. And shareware is more or less a sales model to distribute proprietary software. Free software comes in several forms, and one example, maybe one of the most prominent examples, is the GPL, the General Public License. This is a legal text that explains what rights come with free software and what are the rights and obligations of the user of such software. There are a couple of other licenses as well, like the Apache license, the MIT license, and several others as well. And there are also a couple of websites that compare the subtle details of the single licenses amongst each other. As mentioned, free software has a history of many decades already. The epiphany moment of free software was back in the 1980s, when software developer Richard M. Stallman, RMS, wrote a license agreement for his set of Unix-like tools he called GNU. As of today, many large IT companies have adopted open source to some degree. Even Microsoft published its open source strategy back in 2010. From large mainframes and supercomputers to smartphones and Raspberry Pis, billions of devices run with open source software today. We've talked about the freedom in free software already. But what does this freedom mean? Actually, it's 4 freedoms. And these freedoms are not just a romantic musing from some activists, but they are crystal clear sections from a legal binding license agreement. There are 4 freedoms numbered 0 to 3. Let's start with the upper left freedom. Freedom number 0. This is the freedom to run a software or a program for any purpose. This is the fundamental right to use free software. There are no restrictions on the execution environment. You can run this on any machine under any conditions. Please take note that there is no statement about freedom in terms of free of charge. So to grant this right to someone else, it is completely fine to ask for a fee. The right one, to the right-hand side, is to study the program and to change it to your needs. If you have full access to the source code, you can get some insight into the architecture as well as the implementation of the open source software. It is very important to have this insight to judge IT security measures and ways to mitigate and to fix vulnerabilities once they are discovered. And believe me, most software has bugs and vulnerabilities. It's not a question of if they are there, but only how to fix them on a short-term notice. Freedom number 2 on the lower left-hand side is about redistribution and making copies. This is the fundamental difference to proprietary licenses who prohibit doing so. The transfer to anybody else, to your clients, to your friends, to your co-workers, can be done with a fee or without a fee. This is not part of the license here. But when passing the rights, it has to be done on equal terms. So you have to grant all users that use the software that you are redistributing the same rights as you have been provided with when you got the software. Freedom number 2 is probably the most misunderstood right of all. It is not only a right but also an obligation to grant all rights received to the next receiver of the software. That means that you are not allowed to just grant the right 0 to run the open source software, but not to provide the code as well. Finally, there is freedom number 3 on the lower right hand side that entitles you to improve the program and to release also these modifications. This makes the participation on a software development process possible, and this is commonly done on public repositories like GitHub and other ones. But this also opens the door for contract work. So a company could ask an open source developer to develop a custom feature and give it back to the development process, to the open source development process. Not all licenses make all of these freedoms mandatory. If you're looking for a license, look out for a comparison chart on the internet. The 4 freedoms listed here mainly apply to the GPL, the GNU Public License. There are subtle details on the BSD, Apache, Mozilla or MIT licenses. There persist a few tenacious myths about open source. The first is that only volunteers contribute to open source software. This is not true. The truth is that there are many different models how to contribute to open source projects. So for example, there are companies who are more or less in control of open source. So Oracle is an example because Oracle employs a majority of developers working on the MySQL database. However, other private contributors could also contribute to the source code as well. And then there is a special case of some consortia like the Linux Foundation that is an umbrella organization for big companies like Intel, Red Hat, Samsung, SUSE, IBM and lots of others. And under this organization, individual persons employed by the members contribute to the software. Actually, this model where paid developers contribute to open source is the predominant model today, at least for the larger projects. The second myth is about open source software is free of cost and it is inherently uncommercial. Well, most often open source software can be downloaded free of charge, but it is legal at the same time to sell software for a fee, as long as the mentioned license terms are not violated. Why should a company pay for open source software? Because it gets some form of managed service support or some other special features are developed for this company for a fee. So it's perfectly right to make a business case in selling open source software. And the third myth is that open source is less reliable because anybody can look into the code. But this is a contradiction. True is that the inside of the code is actually a prerequisite for audits and quick mitigation of security incidents. There are software defects in any kind of software. But what is more important is the time frame in which the code gets fixed once defects are discovered. Usually, if we encounter problems in open source software, they are fixed by the course of a day or a few days. Let me summarize the reasons for open source software. First of all, and very obvious, there is seldom a fee for the licenses themselves. This does not mean that open source is free of cost at all from an operational point of view, but at least you can spend the money to do the actual development. A second one is there is no risk of a vendor login. As you have in open source software access to the source code, you can at any time change the code yourself or contract a third party to further on maintain and develop the code any further. You could do contract work for open source software, and by this you have feature development on demand. It's not necessary to be an expert in open source software or the code itself, but there are many software development companies who make a business model from writing code on demand for free software. Open source can be used as an implicit standardization model. As code is developed in the open with open source, a lot of peer review gets applied to the software. That means once it is accepted by the overall community, it is a de facto standard. And the last reason for open source software listed here is a decoupling of maintenance from your own development department. If you contribute to an open source project, it's the project that takes care of the project itself. So you don't have to keep a whole team of developers, since they work together with the community that can be distributed on a worldwide basis. There are two main ways to get in touch with open source software, and let's have a look how they apply to us here at T-Systems. The first is just to use the software. To do so, you need to obtain a license, which is kind of implicit if you just download the software, as by downloading and using and executing the code, you accept the license agreement implicitly. And this license agreement grants you the freedom 0 to use for any purpose. So you run it and you're just fine. Keep in mind that there may be some compliance and liability issues. So if you run open source software, make sure that you can comply with these requirements we may or may not have imposed by regulations or something like that. But apart from that, that's all. Download, run. Nothing else needs to be taken care of. It's slightly different if you plan to contribute to open source. So for example, when we at T-System develop or enhance free software, this is a multi-step process. So starting from the left-hand side, we have public repositories like GitHub, or there are several others as well. And we download the software from these public repositories, most often free of charge. This process is also called cloning. After that, we have the right to inspect the code, to improve it, and finally to redistribute it. But if we redistribute it and upload again to GitHub or give it to our customers or clients, it is important to redistribute the whole thing and to grant also the right to look into the code. So it's very important to keep this in mind, to have at all time access to the code, because this is a very important obligation. Not complying with the legal obligations of providing the modified source code and the whole build instruction is not a cavalier offense. There are organizations like, for example, gplviolations.org that look for companies and organizations that redistribute the software but don't provide the source code as well. This can have severe implications in a legal lawsuit. To prevent this, we have within Deutsche Telekom the TOSCOM, the Telekom Open Source Committee, which provides a little bit of help, and have a look at their You and Me pages with very helpful hints and tips. As we have seen, the open source licenses allows for everybody to contribute to the project. But who's taking leadership? Who gives direction? The open source community developed a well-balanced system of meritocracy. That means members are valued based on their technical excellence. Often projects implement peer reviews. The more a developer contributes, the more respect and trust does he earn. It is about taking and giving, and applies to companies as well as to single contributors. These may start as students or freelancers, but visible participation in open source projects make them very attractive for companies as well. This is why open source developers are often employed by IT companies that allow them to spend a part or even their full time on open source contributions. This is just another way of taking and giving. Open source makes sense for tech people, as we've seen. But is it also suitable as a base for a business model? It is. Look at those 4 examples. SUSE Linux is a Linux distribution vendor. Their business model is to provide maintenance and support. They are very active in the participation at several open source projects of all trades. That includes the kernel, desktops, virtualization, and many more. Second is IBM Corporation. They provide general IT services, not always, but often based on Linux systems. Their business model includes consulting, professional services, implementation of large and complex IT setups. IBM supports strategic projects like the Eclipse, IDE, the Linux kernel, and others, but they are very specific in selecting their projects. They have been renowned to have spent several billion US dollars for open source activities overall, for internal and external activities. The third example is a German company called Nextcloud. They have developed a software for cloud storage. Their business model is software subscription and providing support for that. Nextcloud offers its complete application stack under open source licenses. But still a number of clients pay for the software as they appreciate the support. The company was founded as a fork of OwnCloud, that had a similar service offering, but was increasingly reluctant to cooperate with the community. At a certain point, former employees took the source code, you remember the Freedoms 1 and 2, and founded their own company. The fourth example is Netflix, the video-on-demand company. Their business model has nothing to do with IT at all. They are just a content provider, if only a very big content provider. They don't offer immediate IT services, but to run their services and to run their business, they contribute to many open source projects, for example, for big data, for content integration, continuous integration and continuous delivery pipelines, for application servers and stuff they need for their internal work. Open source itself is well adopted within Deutsche Telekom. Let's have a look at only a few projects that are used within the company. So everybody knows Linux, the operating system, but there are others as well, like the BSD operating system family, like FreeBSD and OpenBSD, which are used in some projects. All of you probably use web browsers like Chrome or Firefox. But even on the very deep backend side for cloud management, OpenStack and Kubernetes are very popular open source based projects. In monitoring, there is iSinger, for example, used in many projects, as well as Prometheus, a very cloud focused monitoring framework. Databases like PostgreSQL and MySQL represent the classic relational database types, but also new types of databases like Elasticsearch and many others are developed under an open source license. Application servers like Tomcat, Wildfly, or even the Ruby on Rails framework are all open source based. The same applies for front-end frameworks. Think of React or Angular. And even the big data and deep learning area is well covered by open source, as Hadoop is a major big data platform, TensorFlow is a deep learning framework that got released under open source licenses. Even if the Telekom is not a creator of software in the first place, software is developed all over the company. Let me give you 3 examples of that. So there is a command line interface tool for easy access and troubleshooting for the API of the Open Telekom Cloud. That was a project initiated in-house for customers and users of the OTC. It allows to access the different modules and services provided by the OTC through a simple command line interface. This is developed under an open source license. The next example is a module for QGIS. QGIS is a planning tool, and a department at Deutsche Telekom Technik in Bremen extended this module for their own track planning purposes. They extended the module for telecom specific road planning. In the third example, T-Systems supports and maintains an official OpenStack module called Zool for distributed continuous integration and continuous deployment projects. The team members contribute to the community-led extension of the module and its node pool component. But the Telekom is not only supporting open source by direct contributions to code, but is, for example, also gold sponsor of the OpenStack Foundation, an umbrella organization taking care of the cloud management tool OpenStack. We've seen the agile approach to tackle complex problems one by one and have learned about the spirit the open source model can unleash. But when both go together, hand in hand, astonishing results can be achieved. Think of a project with more than 25 million lines of code, with more than 1,300 changes per week, contributing with 15,000 developers and 1,400 companies from all countries, from all continents, for more than 27 years right now. Coordinating a project like the Linux kernel requires to combine best agile and open source virtues. It requires communication, trust, decentralization, and a many eyes principle. Have you ever seen the astonishing discussions on the Linux kernel mailing list? The trust the developers have in each other and their subsystem maintainers. The decentralized organization of the development teams. And the peer reviews and the sign-off processes to ensure quality in this project. This is really astonishing. To facilitate this movement, the means are created by the same principles. Have a look with me to 3 good examples on that. So first of all, there's Git, an open source tool that is today the de facto standard of maintaining code. Such source code management is an essential requirement for agile projects. But it's not all about technology. The invention of the so-called pull request is an excellent example for the lightweight agile process we've been talking about. It's a simple, transparent and distributed way of working together in a team, even if team members live in different cities or even countries. But finally, not everything can and should be discussed online. Meetings like the OpenStack Summit, the KubeCon or the Open Source Summit even foster the spirit of this collaboration. This is the foundation of a cultural change. This is new cloud thinking. Thank you very much.
Thank you for your attention. This concludes the recording. Please click the i60 icon to visit our Jam site to access further recordings. If you have a need to create an i60 training for your own topics, please contact us directly by clicking the FMB Global i60 Training Team link on the screen. Thank you and have a good day.